We're given the following adjacency list representation of a graph. Select the shortest path between 0 and 7. So the way this works, you're going to do vertex, parent, and weight. And we'll do 0, 1, 2, 3, 4, 5, 6, and 7. So the rest of these are going to be set to infinity. And then we're going to do a stack over here. So initially we're going to start here and we're going to put in the values into our stack. And so we're going to say 0 to 1, 0 to 2, 0 to 3. And so we're going to investigate this until we find the complete smallest path. So we're going to start out with 0 to 1, and 1's parent is going to become 0, and that's going to be 6 is the weight. So investigate the outgoing edges from 1. We're going to have 1 to 2, 1 to 4, and then 1 to 5. So now we're going to say that 2's parent is 1 is going to be 6 plus 5, which is now going to be 11. So now we put all the values from 2 onto the stack. So we have 2 to 5 and 2 to 6. And so now what are we going to do? Well, 5's parent is going to be 2, and it's going to be 11 plus 7, and that's going to become 18. From here, we're going to look at 5's outgoing, and we have 5 to 4, 5 to 6, and then 5 to 7. So initially we're going to look at 5 to 4. We look at 4, 4's parent will be 5, and this becomes 18 plus the weight between 5 and 4, which is 2, so that becomes 20. Now we have 4 to 7, which is going to be at the top of the stack. So now we're going to say, well, 7's parent is 4, and now we have 20 plus 5, which is going to give us 25. Seven has no outgoing edges, so we can see that 4 only had the outgoing edge to 7. 5 to 4, we investigated this, and now we can go 5 to 6. So 6, we're going to say that 6 is 5's parent. 5 is 6's parent. And instead of being infinity, we're going to say, well, 5's weight is 18, and the weight from 5 to 6 is 5, so this becomes 23. 6 has one outgoing edge to 7. 23 plus 3 is 26, so we don't update it because the current weight to 7 is 25. 5 has an outgoing edge to 7. The weight at 5 is 18. 18 plus 4 becomes 22, which is going to beat the current weight. So now we say, well, 7's parent is 5, and now we update this to 22. So now we say, well, 2 to 5. So 2 to 5 is going to be here, and that's a weight of 7. 2 is a weight of 11. With a weight of 7, that becomes 18. That ties the current score, so we don't evaluate it any further. 2 to 6 has a weight of, 2 to 6 is now 15, which means we beat this 5 here. And now we're going to evaluate everything again since we beat it. Since we have 6, we now have its parent being 2, and that becomes 15. So now we're going to evaluate all these values again. So let's go back to 6 and see what happens. When we go to 6, as one outgoing edge to 7. And so that's 15. 15 plus 3 is 18. So now we're going to say that 7's parent is 6, and that weight is now 18. So now here we can go with 1 to 2. We have a weight at 1 being 6. 6 plus 5 is 11. That ties. So now we can do 1 to 4. 1 to 4. 1 has a weight of 6. The weight from 1 to 4 is 3. So that becomes 6 plus 3 is 9, which beats the current value at 4. So now we say that 4's weight is 1, and that would be 6 plus 3 is 9, like so. And now we're going to start investigating from 4 again. So 4 has the edge from 4 to 7. 4 to 7 has that weight of 5. So now we look at 4, 9 plus 5 is 14, which actually beats the current value of 18. So now we're going to say that this is 4, and 11 plus 5, 9 plus 5 is 14. Now we can investigate 1 to 5. 1 has a weight of 6. 6 plus the weight from 1 to 5, that's going to be 12. So that beats 5's current parent of 18, so that becomes 1 here. And 6 plus 6 becomes 12. So now we can investigate all the outgoing edges from 5. 5 has 4, 6, and 7. So wait, 5 to 4. 5 to 6, and then 5 to 7. So when we go from 5 to 4, we see that 5 to 4 has a weight of 2, and 5 is currently 12. 12 plus 2 is 14. That's more than 9. 5 to 6 is 12. 5's weight is 12. 12 plus 5 is 17. 6's weight is 15. That doesn't beat it either. 5 to 7, 5 has a weight of 12. 12 plus 4 is 16. That does not beat 14 as well. So now we have gone all the way through 1 to 0. 0 to 2 has a weight of 4. So 2's current weight is 11. So we update 2's weight from parent of 1 and 11 to a parent of 0 and 4. From 2, now we can start adding all of 2's values. So 2 has outgoing edges from 5 and 6. So we have 2 to 5 and 2 to 6. 2 to 5 has a weight of 7. 2's current weight is 4. 7 plus 4 is 11. 5 now beats this. So now we have 5's parent is 2, and it's going to be 4 plus 7, which is 11. So it's going to beat that by 1. Again, we can go through and start putting all the elements from 5 out going to the stack. So we have 5 to 4, 5 to 6, 5 to 7. 5 to 4 has a weight of 11 plus 4, which is 15, which is not going to beat that. 5 to 6, 5's weight is 11. 5 to 6 is going to be, so that's 16. That's not going to beat it either. 5 to 7 is going to be 11 plus 4 is 15, doesn't beat 14. And so now we're last but certainly not least, 0 to 3 has a weight of 5. So now we can go through this step here, and we can say that 0 to 3 has outgoing edges from 3 to 2, 3 to 4, and 3 to 6. So 3 to 2, that's current weight 5. 5 plus 3 is going to be 8. That does not beat 2's previous weight. 3 to 4, 3's weight is 5. The edge from is 9. That ties, so that's not going to do us any good. 3 to 6 has a weight of 2. So 3's weight is 5. 6's weight is 15. So that becomes 5 plus 2, which is equal to 7. So here we have this becoming 3 and 7. And then we investigate 6. 6 has an outgoing weight to 7 here with a weight of 3. 7 plus 3 is 10. So therefore, we have once again updated our best path to 6 and 10. So now this means we have investigated the entire thing, which means our path was 7 to 6. 6's parent is 3. 3's parent is 0. Therefore, it's 0, 3, 6, 7. The answer is E.